I'm a plant metallurgist, and my job is to make sure the plants are running as best they can to maximise our production, optimise equipment wherever possible, and liaise with the operators and the other sectors in the mining. So I talk with the mining, the geologists, shipping, even it goes through to marketing. I'm talking with everyone so we can all be on the same page about what we're producing and making sure that my plant's delivering that. So today, just bringing awareness to the fact that what they're learning in school can be used in the industry and is used in the industry, and that it can be fun. So we tried to put a bit of a fun spin on it and to demonstrate it. But also that, especially being a female, you can go into these, usually the male-dominated areas, and you can still go in and do what you're wanting to do and trying to inspire them a little to follow some of their ideas, because at that age it's really hard to know what you want to do. So it's kind of just giving them some options and saying, hey, this is a job, it might fit you, maybe you want to do this. So I went and enrolled in mechanical engineering instead of mechatronics because I didn't like electrical systems. And so I went up to start, and then I thought, no, I'm still not quite ready to do uni. So I deferred it another 6 months and came up to the middle of 2014. I did mid-year entry, and by that stage I'd changed my mind again, and I decided I'd do chemical engineering because I loved chemistry through school. So I went into my chem eng degree, and I finally stuck with that, and I got through it. I failed a unit. I had to redo that unit, so that took another. And during that time, I had to do some work placements for my engineering degree. You have to do work placements, and that's how I got involved with Talus and lithium. So for 2016 and 2017 summer, I worked with Taliesin for 3 months over summer. And in that time, I learnt what it was to be a metallurgist. I'd never heard of metallurgy. I was doing chemical engineering, so it's not metallurgy. All right, so we get mixtures. All right, we're going to use this lovely mixture of food, but we're going to pretend it's minerals. Okay, so we get mixtures like this that come to our plant every day, and our job as a metallurgist is to be able to separate them into the individual streams. When we look at this, how can we tell, how do we know the difference between the marshmallows or the Maltesers or sultanas? So what kind of things are we looking at that tells us that they're different? All right, so this is something we use at work, and if you have a look at the screen behind you, there's actually a video of a screen that we have at work. Okay, so that's one of the ones that's got rocks, and we've got water jets to help push through the screen. But what do you notice about that screen? Yeah, good, okay, so we need to stir it, all right, because we've got all this coconut stuck at the bottom. Okay, so the same thing happens in a plant. So there's your stir. Okay, so at the plant, we've got lots of things. We've got agitators in most of our tanks, okay, to help agitate things, to help mix them so that the particles don't get trapped within one another. Okay, so the same things that's happening here, we do in our plant. Okay, so the peanuts are also coated in oil. And what do we know about oil and water? Separation. Yeah, it separates, okay, because oil is hydrophobic, so oil repels water. Or water repels oil, whichever way you want to do. So I'm going to filter these again, and then we'll be left with our sultanas as well. Okay, so the oil on the peanuts is hydrophobic, okay, and we use this in the plant as well. There's more flotation happening behind. Okay, so the oil that's coating it has the hydrophobic, wants to get away from the water, so it's going to attach to the air bubbles that are in the water. So the soda water is creating air. The hydrophobic stuff goes, there's air and not water, let's grab onto that, okay? And then the air floats, and so does the stuff that's attached to it, which in this case is the peanuts. I love that I get to go to work every day and work with a wide range of people that all have the same goal in the end. And getting to work together to solve the problems, it's really very rewarding when you get a problem and you get to work through the solution, and you're talking with all these different people, you come up with a plan, and then you solve the problem in the end. And sometimes you can optimize it. I'm still early in my career, but I watch the other metallurgists, and they come up with ideas. They look at the plant and they say, maybe if we do this we can improve it, and they end up making the company an extra X amount of dollars, and it's just that's really inspiring to see. So I love being able to do that. STEM skills are extremely relevant. your science, I'm in a science-based industry, we're doing metallurgy or extractive metallurgy, so we're using chemistry and science to separate our minerals. That's the core of our process. And then you've got technology in the way that we analyse it. So we're using so many data collection things. We're using online analyzers. You know, you're always using this new technology that's coming out and about. So not only are we using it, but some companies, you know, you think we really need something to do this, but there isn't anything. So then you can start to develop stuff, you know, or you might just, it might only be like a little backyard get-together sort of random thing that you've made, but it works for your plant. And then other people start to say, oh, that's works really well, maybe we can use it in our plant. And then before you know it, you're designing technology things. And engineering is the problem solving and, you know, the analytical side, I think, you know, being able to nut out the problems and find that solution to it. And maths is every day. Every day we use maths. Thankfully we have calculators though. So. I think the biggest pointer for me to give to them is there's an infinite amount of you know, occupations now that use STEM skills. You can almost make your own job now, which is really cool, but also really terrifying because there's not just one answer to the what should I do question. You know, there's now an infinite amount, and knowing or trying to figure out what the right one is really hard. So it's not so much that there's, you know, one job for one person. I think there's multiple jobs that you can do, and yeah, I guess using STEM skills using the STEM skills, don't be afraid to use them, and yeah, you don't get caught in your stereotypes that, you know, if you follow a STEM career, you have to be really smart, or you know, you're really nerdy, or you're one type of person, because it's not true. You know, such a diverse range of people that I've already worked with so far, and yeah, it's very open. I think it opens your entire range of options if you consider STEM careers.